Welcome back to our video on types of research studies. The first half of the video was about observational studies. The second half of the video is about experimental studies. Remember, we still haven't figured out what it is exactly that causes a person to turn into a magician. Just remember that all the data in this video is made up. So it's time to go on to an experimental study. Hard to do an experiment with 100 first graders, but pretty easy to get 20 college students to participate in your study. So you get 20 college students, you put 10 of them in a room to watch magic shows on TV for a few hours, you put another 10 to watch tennis matches on TV for a few hours, and then you give them both a magic test. And it turns out that the people who take the magic test, who watch the magic TV shows on TV, take the magic test, get about a 37. The people who watch tennis on TV get about a 30 on their magic test. So it does seem like there's a somewhat of a relationship here. The more TV you watch about magic, better you are at magic. Of course, an experimental study, by definition, is when researchers manipulate one variable to see if it has an effect on another variable. And as you probably know, the independent variable is the one that the researcher manipulate or change. It's also called the explanatory variable or the input variable. And it's on the x-axis. And the dependent variable is the one researchers measure to see the effect of the independent variable. It's also called the response variable, and that is put on the y-axis. All right, so you've done this study, and you're wondering, is it replicable? Other magicians now are interested, other scientists are interested in this study that you've done, which seems to show a relationship between watching magic on TV and being a magician. But these other scientists around the world, maybe they haven't been able to replicate your results. So what went wrong? Well, maybe the scorers in your test actually knew which group each person was in. For example, everybody finishes watching TV, they come out, you or your scorers know who was in the magic show TV room and who was in the tennis match TV room, and they kind of expect the people that were watching magic on TV to do better, so they just subconsciously give them a better grade on their magic test. Another thing that could go wrong is the selection process itself could have skewed the results. Maybe you advertised this study as a study into how to become a magician, and so the people that were really interested in this rushed to join the study and arrived first at 2 in the afternoon and got put into the room of people that watches magic shows on TV. And then you still needed, come 2:30, you still needed 8 more people for your study. So you go out and find whoever you can and put them in the tennis match TV room. And of course, now the people that are watching the magic shows are already better and more interested in magic because they have been looking into it all their lives, possibly. There could be all kinds of confounding factors. Maybe the people who take the magic test and who had watched magic shows on TV had clothing that made it easier to do magic tricks. Maybe there were some instructions on the TV show about how to do magic that the tennis watchers did not get. Any number of things could have confounded this experiment, so we need to design a better experiment. And that is where the double-blind randomized control trial comes in, the RCT. It's called the gold standard of experiments because it does a couple things. First of all, it double blinds. In other words, neither the subject nor the experimenters know who has gotten the treatment. Hard to do with our experiment. Fairly easy to do in medicine. You use a placebo and you don't know who's getting the placebo and who's not. Even the experimenters don't know. They all have numbers on them that go back to some code somewhere that a third party will match at the end of the experiment. In our case, we could possibly have our magic show TV watchers watch 5 different shows, only one of which is a magic show, and our tennis watchers watch 5 shows, only one of which is a tennis show, and then we can test these people on a variety of things. Somewhere in there is mixed some magic skills. And so nobody really knows what the experiment is about, so they don't really know if they are in the experimental or the treatment or the control group. The other part of the RCT, of course, is the random. But this is easier to do. Subjects are either assigned randomly to the experimental group or the control group. You've done all this research, years of research. You're trying to put it together, trying to decide, can I really believe that watching magic TV will help me become a magician? There's a few ways to answer this problem, this question. The first is the dose relationship. Is there a dose relationship? In other words, as I watch more TV, does my magic score go up? And it turns out that in this particular graph, in this particular result that you have found, it turns out that everybody starts with about a 37% on the magic test. But for every hour per week they spend watching magic shows on TV, their score on the magic test goes up by 1. So if you happen to watch 5 hours of magic shows on TV, your score on the magic test will probably be about a 42%. That's a dose relationship. The second question to ask is, does it fit with existing understanding? Is there some mechanism that relates the two variables? And in our case, there kind of is. The more TV I watch, the more tricks I might learn. The more TV I watch, the more nuances and flow I might pick up from the professional magicians that might make me a better magician. The more TV I watch, the more I may become motivated to become a better magician. So there does seem to be a reasonable mechanism here relating the two things. Then you'll have to ask, is there a more likely alternative explanation? Well, there could be an alternative explanation. Maybe magicians run in families and they all like to watch each other on TV. So the more magic you do, the more your family grows, the more TV you watch, the more magic shows you watch on TV, rather. There might be an alternative explanation, but I think our original explanation was pretty good. It probably is the most likely explanation. You still want to know a little bit more. Can I really believe this result? And so then you do a meta-analysis. Now, when you started this research about 20 years ago, people became interested and they started doing similar research. And they did research, different people in many different countries, in Japan and Peru, different aspects of the question, different age groups. So now there's been a lot of research on this issue. You gather it all together and you do either a meta-analysis or a summary review. They're similar, a little bit different. A meta-analysis takes all the studies, decides which ones are credible and can be combined, and then they combine them into one simple study, or one large, not very simple study. You maybe have 20 studies with 20 subjects each to begin with. You combine it all, so it's like you're treating one study with 400 subjects. And so such a large study, you get rid of random error, you get more significant results. That's what a meta-analysis does. Pretends all the studies were one. A summary review is not so technical. You just read all the 20 studies, you find out, oh, well, 17 of these good studies say there is a relationship between watching magic on TV and becoming a magician, and 3 say no. Well, 17 is more than 3. I think I can go with the 17. That's what a meta-analysis or summary review does. There it is. To sum up, a meta-analysis or a summary review is looking for a convergence of results. So we've reached the end of the video. I hope you've learned a little bit or reviewed what's retrospective versus prospective, what's experimental versus observational, how to tease out whether there was a cause or just simply a correlation, and what a meta-analysis is. So I hope to see you next time, and have a great day.